Hello learners, in the past two lessons we have learnt about present value of money, future value of money. I hope you have a fair idea about both of these concepts, and also I expect that you remember the concepts and the formula which we learned in the past two lessons. Now today I have kept this special session for you so that we will learn about how to practice the application of present value of money and future value of money. As I told you earlier, both of these concepts have a great application in the finance as well as for the layman also. For a layman, if he is taking a loan, he is interested to know how the installment of a loan, that is equal monthly installment or equal annual installment of a loan, is calculated. Similarly, an individual investor might be interested to know how much he should deposit year on year or month on month to accumulate a particular fund. That means application of time value of money for sinking fund. Similarly, a person might be interested to go for the retirement planning, so that he can deposit a certain amount year on year or month on month to have a sufficient corpus when he retires from his job, and that corpus can be used to give him something like regular income. So, all those applications I am going to explain you with the help of detailed explanation. So, let us begin with the first example of this practice session. The first example, as you can see, what we have, Mr. Hakka Bakka will receive 2000 at the end of every 6 months for a period of 5 years. If the rate of interest is 10% per annum, then what is the present value of this annuity? Now, as you can see, last time what we learnt, present value of an annuity. Now, in this case, if you see, if I put it on the timeline, 0 time means the today's time, then every 6 months, he is going to get 2000 rupees. That means up till 10th year he will be getting this particular annuity. So, we can say his AA, that is PMT we call it as, is 2000. Now, practically years are 5, but in a period of 5 years there are 10 durations of or 10 spells of 6 months. So, applicable n in this formula will be 10. So, how we have arrived at 5 years multiplied by 2, because in a year we are getting 2 installments. Then annual rate is 10%. So, effective R to be used in this formula will be 10% divided by 2, that is 5%, written as 0.05. So, our parameters are ready. Now, we can calculate present value of this annuity. So, PV is equal to 2000 multiplied by PVIFA at the rate of 5% for 10 periods. Now, if you are handy with the table, you have the table with you, we can locate the factor in the table, else we can use the formula also. So, let us see how the table looks like. So, in the table you can see, this is present value of an annuity table. This table tells you present value of rupee 1. So, 5% will come from this side, 10 will come from this side, and our corresponding factor is 7.722. This means if every 6 months you are going to get rupee 1 for a total duration of 5 years, that means 10 times during the 5 years, then present value of all those 1 rupees coming to you successively is 7.722. But in our case we were getting 2000 every time. So, we do it like this, 2000 multiplied by 7.722. So, this becomes present value of that annuity. So, we get it like this, 15,444. That means to say this particular person who will get 2000 every 6 months, he is ready to pay 15,444 right now. Let me cross check my calculation. 7.722 multiplied by 2000 is precisely 15,444. Now, I will tell you how this particular time value concept can be used to calculate installment of a loan. Let us go back to our old example or previous example. This person has taken a loan of 15,444. So, what is the loan amount he is taking at time 0? Is 15,444, and bank says bank's rate of interest is 10% per annum and loan is to be repaid in equal half yearly installment, over a period of 5 years. It means now we know the loan amount, but we do not know the installment amount. We know the rate of interest, we know the number of installments. So, number of installments are 10, because in 5 years there will be 10 installments of 6 monthly duration. Half yearly interest rate will be 5%, because yearly is 10%. So, what we can do? We can use the same formula. Let me depict the formula once again for you. So, this is our formula. Now, practically present value is the present value of all the installments you will be paying in future. So, that we know. So, loan amount becomes present value. PMT or equal half yearly installment is not known to us, but this factor we just located in the table. So, it was 7.722. If you solve this equation, value of AA will be 15,444 divided by 7.722 gets you 2000. It means if this person is getting a loan of 15,444 today, rate of interest is 10% per annum, equal half yearly installment for 5 years will be 2000 rupees per half year. So, that is the way we can find the application of this present value of an annuity formula for calculating loan installment. Just to remind you, if your installment payment frequency is yearly, use the rate yearly, and number of installments which you will be paying will be equal to n. If your installment payment frequency is half yearly like it was in this case, so take the n equal to number of installments you are going to pay, number 1, and rate has to be half yearly. Similarly, for monthly, number of installments you are going to pay is n and rate should be monthly. So, that is the way perfectly you can calculate installment of a loan. So, that is the application of present value of an annuity. In this case, every time installment was being paid at the end of the period, like end of 6 months, end of 1 year, end of 1.5 year and so on. If it is payment in the beginning of every period, then apply the fundamental of present value of an advance annuity. So, that is the way we have learnt about application of PVI-FA, present value of interest factor for an annuity, to calculate the installment of a loan. Now, let us proceed further. So, this is the solution again, you can see that is there in the PowerPoint. Now, the same factor, present value interest factor for an annuity, can be converted into capital recovery factor. Capital recovery factor is simply a factor which helps us in recovering the capital. So, that is the same thing, reverse application of what we have learnt so far. Then the same example is there. So, I will require you to practice this example on your own. Let us read this and understand that. Mr. M has taken a loan of rupees 1 lakh at the rate of 8% per annum. The loan is to be repaid in 6 equal annual installment starting from the end of the first year. So, question is simple. He will be paying in total 6 installments. So, n becomes 6, R is 8%, and loan amount which becomes like PV of an annuity is rupees 1 lakh. So, you can very well apply the same fundamental which I did it few minutes ago for calculating the installment. Then the second application is sinking fund factor. In sinking fund factor, we will be making an application of future value of an annuity factor. Now, what is a sinking fund? Sinking fund refers to a fund in which at a successive interval person is depositing certain amount to accumulate definite corpus at the end of the sinking fund duration. Let us say you invest rupees 100 per month for 5 years. So, how much corpus will be there with you? By corpus I mean your deposited amount and the interest earned on your deposit. So, how much corpus will be there at the end of 5th year? Like you know, in banks also, in post office also, we have recurring deposit. Every month you deposit certain amount and it piles up to some corpus which is capital deposited by you and the interest earned on that capital. So, sinking fund is like that, and how much we should deposit to accumulate a particular corpus, that solution can be arrived at by applying the fundamental of future value of an annuity. So, sinking fund factor is simply 1 divided by FVI FA at a particular rate of interest for nth period. So, this is the way we can apply this one. So, first one formula is for the end of the period deposit, that means you will be depositing money at the end of every successive period, and second formula is if you plan to deposit in the beginning of each period, then second formula has to be applied. That means we are going in for the future value of an advance annuity. So, let us take this example. Mr. Jigson wishes to accumulate 2 lakh rupees at the end of 8th year from now. He plans to deposit an equal annual amount during these 8 years in a bank account starting from the end of first year that offers an interest rate of 10% per annum. Find out the amount to be deposited in each of these 8 years. So, he has already decided corpus, how much he wants to have at the end of 8th year. That is basically sinking fund corpus he wants at the end of 8th year. So, let us see. So, if we see the future value of a regular annuity is like this, PMT or annuity amount multiplied with FVI FA at certain rate for nth period. Now, in this case future value is the corpus required at the end of the sinking fund duration. So, that is known to us rupees 2 lakh. But PMT, how much he should deposit every year, is not known to us, and that is what we have to calculate. This factor we can locate in the table, FVI FA. Now, what is the rate of interest? 10%, and since duration is or interval is yearly, so rate will be yearly. So, at 10% for 8 periods. So, you can use the table at 10%. So, this rate is 10% practically. So, at 10% for 8 periods. So, let us see, we also have future value table with us, and if you do not have the future value table, you can apply the formula explained to you in the previous lesson. So, let us look at this future value of an annuity of rupee 1. Our rate was 10%, and he will make a deposit for 8 years. So, rate will come from the top. From this side we read the year, it means 11.4359. So, let me verify it whether we have taken the correct table or not. So, 1.1 sorry, raised to the power of 8 minus 1 divided by 0.10. So, 11.4359, precisely we have taken the correct table. Now, what this particular 11.4359 means? It means if you deposit 1 rupee every year for 8 years, at the end of 8th year at the rate of 10%, this money deposited by you accumulates to 11.4359. So, now we go back to our factor. So, you have to note down this factor and check the solution, how the solution will come. So, here we are. So, 2 lakh was the corpus to be accumulated. PMT was not known to us. So, 11.4359 is the factor. So, solve for the PMT. Pretty simple. It means PMT becomes 2 lakh divided by 11.4359. So, if you work it out, that means to say every year he needs to deposit 17,488.78. So, if he deposits at the end of every year for next 8 years this money, he will be able to accumulate rupees 2 lakh at the end of 8th year. Now, in this case he is depositing the money at the end of every year, but generally when we go to a bank, open such account, we start depositing in the beginning of every year and reap out the money at the end of the term of the deposit. So, how do we do that? So, let us take the same example, and if it is deposited in the beginning of every year, so what will be the future value factor like this? So, future value of an advance annuity, that is annuity due, is PMT multiplied with FVI FA at certain rate for nth period, and this is further multiplied with 1 plus R. Now, if you solve this equation to find out the unknown PMT, so what is my future value required? 2 lakh. PMT is not known to me. This factor we just located, FVI FA, at the rate of 10% for 8 periods. So, that is what we located, 11.4359 and 1.10, because 1 plus R will become 1.10. So, now what we get it? It means PMT is equal to 2 lakh divided by 11.4359 times 1.10. So, we will get the answer. So, 11.4359 times 1.1. So, we get it 2 lakh divided by 12.5795. So, 2 lakh divided by this factor, we get it 15,899. It means in the beginning of each of the year for next 8 years, he needs to deposit 15,899, so that his corpus will be 2 lakh at the end of 8th year. So, this is the way we can apply the fundamentals of future value of an annuity to create a sinking fund. Now, one interesting fact I will let you know this time. Whether we should apply future value interest factor or present value interest factor, that is the tricky situation. Now, always remember, if accumulation of the money is taking place at some future time, like in this case 5 years, 10 years, 8 years and something like that, and year on year you are adding something, month on month you are adding something. So, you are standing at 0 time and something has to be accumulated, lump sum money has to be accumulated at the end of the future period. Apply the future value fundamental. On the other hand, accumulation has taken place in the beginning, like in case of a loan. If you take a loan, accumulated money comes to you right now, and year on year, month on month or 6 months, you are paying the installment. So, accumulation is taking place at 0 time, and you can see in the previous example of loan taken for 2 lakh rupees or whatever amount it was, 1 lakh rupees, accumulation was taking place as 0 time. So, we applied the fundamental of present value factors. So, that is simple trick. If accumulation is taking place in future, apply the fundamental of future value. If accumulation is taking place at right now, apply the fundamental of present value. So, this is the trick to identify which fundamental to apply. Now, we go for the mixed application of present value fundamental and future value fundamental. So, that will be the last application from my side for the time value of money. Retirement planning. Now, for retirement planning, if you can see, Mr. X is of 35 years today. He will retire from his service at the age of 60 and he expects to live till the age of 80 years. It means he has 25 years more of service, and once he retires at the age of 60, he will live till the age of 80. Now, what is there? He plans to invest a particular amount every year during his service period, that means for next 25 years, is unique amount, same amount every year to be deposited, so that he can have a sufficient corpus in his retirement fund, and as soon as he retires at the age of 60, from the age of 61 years he needs every year a lump sum amount, one unique amount for his expenses. So, he has estimated that every year during that period he will be needing 12 lakh rupees. So, first 12 lakh he wants at the age of 61, second at the age of 62, and last at the age of 80, and he will keep on depositing the money right from the age of 36 years till the age of 60. So, let us solve this. Rate of interest, what he is assuming? He assumes that when he starts depositing from the age of 36 till 60, a mutual fund which has a fair return of 10% per annum will give him 10%, that is the expectation, not a guaranteed one, and at the end of 60 years age, subsequent period rate of interest is 6%, because he will be reaping out the money. So, definitely he has taken a concept of 6%. Now, let us solve this, how it has to be solved out. Now, you can see, if I put the things on his timeline, today he is of 35 years, he will retire at the age of 60, expects to survive till the age of 80. So, that is the age graph or age timeline. His first deposit will come when he is of 36 years, and his last deposit will come when his age is 60 years. He wants every year from the age of 61 rupees 12 lakh till the age of 80 years. So, during this period he will be depositing 25 equal annual installments, and rate of interest at this rate is duration is 10%. During this period he will be making 20 withdrawals in such a way, that is 12 lakh per annum, so that at the end corpus becomes 0. It means he will have equal annual withdrawal of 12 lakh for 20 periods, and rate of interest during this period is 6%. Now, question comes whether we should apply present value fundamental or future value fundamental. Again, I will take you back to the same concept. You are right now, you are standing at this stage, we will solve it through a backward procedure. If you see, from this to this, he will keep on making the withdrawal. It means when he is of the 60 years age, he must have sufficient money in that bank account, or corpus should be sufficient enough, so that every year he can withdraw 12 lakh rupees and account balance becomes 0 at the age of 80. That means accumulation is taking place at the age of 60, whereas money is being reaped out in installments subsequently. So, for this particular period we will apply the fundamental of present value interest factor of an annuity. So, we will solve that, so that we know how much corpus is required at the age of 60. So, let us solve it out. It means I do not know the present value, but I know the PMT, that is 12 lakh he will be making a withdrawal, PVIFA at the rate of 6% for 20 periods. So, we get it, 12 lakh is required. This factor we can calculate or we can locate in the table. So, let us locate it in the table. So, if you have handy with the table, you can see the table. So, let me calculate it out. So, it will be calculation formula, I can let you know, 1 minus 1 upon 1.06 raised to the power of 20, and this answer is divided by 0.06. So, 1 upon 1.06 raised to the power of 20. So, we get it 0.688195 divided by 0.06. So, this factor becomes 11.4699. So, in the annuity table in the row of 6% and in the column of 20 years, you will get this factor. Now, if you multiply it with 12, you will get it. He needs to have 137.639 lakhs as a corpus. So, if his corpus at the age of 60 is 137.639 lakhs, then he can comfortably withdraw 12 lakh rupees per annum till the age of 80, that is 20 installments. Now, that was the first part. In the backward tracking, we have solved out present value of an annuity fundamental. Now, to accumulate this corpus at the age of 60, what he needs to do? He needs to have how much he should deposit every year from the age of 36 till the age of 60, so that his first withdrawal of 12 lakh comes at the age of 61. So, again what we have, future value of an annuity is equal to PMT, that is annuity amount, multiplied with FVIFA at certain rate. In this case, it will be 10% because he is expecting 12%, 10% return for 25 years. So, remind you, this is 25. Now, future value is known to me. That means, I wish to accumulate 137.639 lakhs. So, what we can do? We can proceed with this one, 137.639, you should remember. So, 137.639 is the future value to be accumulated at the age of 60. PMT is not known to me. I multiply it with FVIFA at 10% for 25 periods. So, if we calculate FVIFA, so it is 1.10 raised to the power of 25 minus 1 divided by 0.10. That is the formula we have. Now, we can quickly solve it out. So, it becomes 98.3471. Now, if you plug in the value, 137.639 is equal to PMT multiplied with the same factor 98.3471. That means, my PMT becomes 137.639 divided by 98.3471. I will get the answer 1.3995. That means, every year he needs to deposit 1,40,000 for next 25 years, and he will have a sufficient corpus to accumulate this much money at the end of 60-year age, so that from the age of 61 he can withdraw 12 lakh rupees per annum. So, that is the way a blended application of PVIFA and FVIFA can be done for retirement planning. So, dear learners, I hope you have understood both the concepts. My only submission is that keep on practicing. If you have any doubt, you can reach out to me also. You can read the material or you can see the video. Everything is self-explanatory, explained very well. Keep on learning. Thanks a lot. Wish you good luck.